Hello, everybody. Welcome to GDC and this session. So my name is Brian Peak. I'm a developer advocate over in Azure Gaming, and today I'm going to talk to you about how you can unlock the potential of your game's data using Microsoft Azure. And I was also tell you to turn off your noisy things and to make sure you fill out sessions at the end and tell us how wonderful or how terribly we did. So let's get straight to it here. What we're going to talk about today specifically is about our Azure database services and how you can store data in the cloud and use that data to actually improve your game throughout the life cycle of your game. So there's three key points that I want to make in this session, and that's bring what you know. You don't need to learn anything new here. You don't need to learn a new database technology unless you want to. If you want to, sure, come and try something brand new that you never used before. But if you know and are familiar with a relational database or with NoSQL databases and what that means, we have a managed service for you that's going to get you where you need to be. The second part is let us help you manage it. So don't worry about having to patch VMs and operating systems and SQL Server and other database things. We'll handle that for you. Don't worry about global scalability. We can replicate data for you. Don't worry about backup and restore. We have services that'll do that sort of thing for you. Overall, spend the time where it matters, building your game, not running IT on the back end of all of this stuff. And then finally, it's just as kind of a bonus of having your data in Azure, we have a variety of analytics, visualization, machine learning services that plug into all of our database services. So you can easily take that data out, run operations on it, learn more about your game, about your players, about their behavior, and make your game better. So let's dig into some of this stuff here. Talk just briefly about the Azure Global Network, the Microsoft Global Network. It's one of the largest private networks in the world. We have 54 regions throughout the world. And what this means for you is that this puts data centers closer to your players. So in terms of performance and latency and whatnot, you're going to have data centers that are near your players across the world instead of having to send them to a place that might not even be on their continent. Tons of fiber. We have our own fiber that we've laid, as well as fiber that we lease from other networking and providers and ISP. But one of the cool things about our network is that between data centers, it's a private network. Your data never hits the public internet. So as you're replicating data, whatnot, across data centers or accessing it between data centers, it's always inside of our private network, which is better performance, higher security, things like that. If you're interested in this sort of infrastructure stuff, take a look at that aka.ms link at the bottom of the slide, which will give you a ton of information just about the global infrastructure of the Azure network. It's pretty interesting stuff. And today we have a lot of partners that are using Azure for games. So publishers from like Ubisoft runs Rainbow Six Siege in our cloud. Next Games, Walking Dead, No Man's Land. IO Interactive, the first Hitman game came out a year or two ago, was all running inside of Azure. And of course, our first party stuff like Forza and Halo, Forza Horizon, Forza Motorsport, all run inside of our cloud as well. So a lot of different companies that use this for games today. We're going to dig into a couple of these as we continue the session. So you'll see how those companies are using the cloud and how their data is in the cloud as well. So let's talk a little bit about our database offering. So we have a variety of different things that you can use. So if you're into relational databases, kind of the main feature set we have is Azure SQL Database. Or if you're into more open source databases like MySQL or Postgres, MariaDB, we have managed services for those databases as well. And one of the points to make here is that a lot of times people hear Azure, they hear Microsoft, and they say, oh, well, Azure is just Windows. And that's just not true. We are very open source friendly. Depending on services, you can run Linux, you can run Windows. It's pretty language agnostic, so if you're using Azure functions, you can write functions in C# or Java or Node, or whatever you want to use, we'll basically be able to handle it. So again, this concept of you don't need to necessarily learn anything new unless you want to. And then our in-memory database service, if you're looking for something like Redis, we have a managed version of Redis that is just kind of driven for you and managed for you. And then finally, for NoSQL databases, our solution is called Azure Cosmos DB, which allows you to store different data types like document or key value, whatever you would need to do. And we're gonna dig into all these as we go through the session. But just know that there's probably a solution in here for you depending on what your needs are. So to go into our relational database platform, all of them are built on this common database services platform. And that means you get some shared features across all of our relational database. You get some intelligence things, which we'll look at for advising you about where performance issues might be, how to tune your database in order to get better performance out of it. Flexible on-demand scaling, kind of comes across the board with all of our databases. So you need to scale up because your game became super popular at launch, and then 6 months later it's not quite as popular. You can scale those things up and down in the portal and pay for what you use. And it's trusted. We have engines and services that are going to make sure that your data is backed up and restorable. We're checking to make sure that your database backups actually work. I don't know if you've ever been in that situation where you're backing up your data every day and then you go to restore it and the restoration doesn't work. We're testing those things in the background to make sure that your data is always safe. We also have high availability and disaster recovery with replication between data centers across the world. So if something catastrophic happened in one data center, your game can continue running across another data center. And these are all built on top of our standard Azure Compute and Azure Storage services, which run everything in our cloud. So these are things that are definitely tested, scalable, and highly available at all times. And then over on the left, there's a kind of a vertical blue box here, which is just kind of showing that because all these services all are built on this common infrastructure, they all plug into a lot of our visualization, analytics, and machine learning services, which we'll get into as well. So let's dig into Azure SQL Database a bit. So I keep hitting the side button on my mouse. So as you might imagine, this is a managed version of SQL Server, essentially. It's SQL Server as a service is probably the best way to put it. So if you're familiar with SQL Server, this is you running SQL Server without having to deal with virtual machines, without having to deal with licensing and things like that. You just pay for a hosted version of it. There's a ton of built-in intelligence features, which I'll show you in our portal. So this can, as your game is running and you're running queries against the database, you are adding data, updating data, whatever their backend is doing, there are features that are going to look at that to make sure your database is secure. They're making sure people aren't running SQL injection queries against your database. Your indexes are built properly, places where you could add or remove an index to perhaps increase performance. With SQL Server, by default, full backups every week, differential backups every 12 hours, log backups every 5 minutes with a retention of 7 to 35 days. And that retention depends on what tier of the service that you're using inside of SQL Server. And what's also great is it's self-service point-in-time restore. So if you want to, something bad happens, you need to restore your database, you go to the portal, you click some buttons, and your database will start a restoration procedure. You don't need to call anybody. You don't need to do anything. You can manage all of this yourself to go back to a point in time whenever you need to. And we have a lot of migration services that'll help you. So if you're running on-prem today or you're running in a different cloud, there's the Azure Database Migration Service, which will help you get your data from one location into Azure. So you don't have to worry about creating backpack files and uploading them and dealing with these things. There are services in here that will help you do all of that. And also, if you are an existing SQL Server user, perhaps you're on-prem and you've bought licenses for SQL Server, and obviously you don't just want to throw that money away, we have a product called SQL Database Managed Instances, which is kind of this hybrid solution that gives you the managed version of SQL Server, but allows you to bring your licenses into our cloud and pay for your usage with those instead of paying as you go. So, and then at the very worst, if you didn't want to use that, you could certainly host SQL Server in a VM, but you don't get, obviously, the management features that come along with our hosted services. But just know that you can go from 100% cloud to a hybrid solution to manage your own solution depending on what your needs are. So just to kind of prove this out, we did a stress test on elasticity and restorability. So we replicated an environment of one of our partners that uses Azure for a very large game, and just kind of wanted to see what would happen in a catastrophic failure. So this is a system that has 60 terabytes of data, perhaps more, across literally hundreds of SQL Server instances. And what we did was we truncated several tables, and this would simulate maybe a game-breaking bug. Maybe there was a bug in the game that wound up deleting data accidentally, or a CI/CD pipeline issue that wound up corrupting data. So we were able to actually take from that truncated 15 tables, we were able to restore all 60 terabytes of that data to what it looked like 40 seconds before the corruption occurred. And we did that in under 2 hours. So that's a ton of data in a pretty small amount of time. And then with the elasticity available in SQL Server, we were able to burst up capacity. So while this huge database restore was occurring, we could just slide the slider in the portal and say, well, I want two instances of this SQL Server. One to run the game while it's still in production, because we don't want to take the game down while people are still playing. And one that's just going to handle all that restoration so people aren't, so there's no performance impact on the game itself. So we did that, and then we could kind of merge the new data in with the restored data, so none of the data was lost, and then scale it back down to just the 1x instance. So you were only really paying for that extra capacity for the 2 hours it took to do that restore. So that was pretty interesting. So just high performance and knowing that your data is safe. There's another partner that has a pretty large mobile game, and they've architected it with, this is another situation where there are literally hundreds of SQL servers that are running at global scale. In their first hour of launch, they were able to run 500,000 queries per second against the system and store about 1 gig per second of transaction logs during that first hour, which is a pretty insane amount of data. As it's running today, over 12 billion player events per day are being stored with hundreds of billions of rows per month. It's a ton of data. And with some of the features like in-memory online transaction processing with OLTP and column store index compression, essentially these kind of these are made for these super high transaction systems. So rather than immediately persisting things to disk, it might persist them in memory and allow you to use an in-memory version while it's in the background putting stuff to disk. And because their data was pretty highly compressible, they were able to take 400 terabytes of uncompressed data and actually turn that into only 20 terabytes of compressed data, saving them money because they don't have to pay as much for storage. And they also use read scale-out replicas pretty regularly for this situation, and one of the places they use it is in their customer service department. So people might have a problem with their game. Hey, I was playing the game and I collected this weapon, but it's not showing up in my inventory. So you want customer service agent to be able to go in and review the logs and the transactions that happened that would have shown whether or not they actually picked up that sword. But you also don't want the customer service agent to screw something up, to be able to write to that database to break something. And you also don't want to have a performance penalty because now they're running maybe scans across the table that might impact runtime performance. So with these read scale-out replicas, they just have a read-only copy that's constantly up to date that they can use in order to handle these customer service inquiries. So let me go into a demo here about some of the intelligence features that Azure SQL Database has. I'm going to switch over to a browser here. Make sure I get the right one. This one here. Oh, got to exit out of PowerPoint. There we go. So this is the standard Azure portal if you've been in Azure before. And I've got a couple of demos set up here. First one I'm going to click on is this Workload Insights demo. And I'll zoom in and out here as necessary. But one of the things I want to show you is over here there's this intelligent performance section that exists on all the databases that you might have inside of Azure SQL. And if we go down to Performance Overview, over here on the right, we'll get a dashboard of all the things that live under Performance Overview on the left. And I'll just drill down into the ones on the left here. So the first thing you'll see are performance recommendations. So again, as your database is being used, Azure SQL is looking for places where maybe you're doing something that's not as optimal as it could be. An example here is parameterized queries. The entire database is using non-parameterized queries, and it could be causing performance issues. If we drill into that, we can see that it's having a high impact. We could save up to 22.56% CPU with query durations decreasing by up to 0.7 of a second. So from here, I can click on View Script and see what the script would be in order to apply this optimization to my database. Or if I click on Apply, I could just do it. I don't have to open up SQL Server Management Studio or another SQL tool in order to apply that. If we go back to recommendations, there's one here for drop index. It says that there's a duplicate index on this table that's wasting about 145 megabytes of data. Again, I can view the script of what it would take to drop that index, pretty simple, or I can click Apply and have it happen automatically. And on this one, you notice there's also a checkbox that I can automatically apply drop indexes in the future. So I can have just SQL Server automate this for me. I don't actually need to go in and look at this dashboard every day to see what's happening. I can just say, hey, if you think I should drop an index, just go ahead and do it. But that sounds scary because it's SQL Server monkeying with your data. So what SQL Server does is it always remembers the last known good plan. So if you have it automatically do this, and it'll check to make sure that performance actually increased. If it didn't, it'll roll back the change like nothing ever happened. So you might get that couple requests where it maybe wasn't quite as optimal, but it'll know that it wasn't and roll it back immediately thereafter. So it'll always go back to a known good state. So you don't have to worry about it if you don't want to. But again, this is opt-in. If you don't want SQL Server doing this for you, you just opt out of it, and that's just fine. The next thing to look at is query performance insights. So this dashboard will show you the top 5 queries that are being run against your database in terms of CPU, data I/O, or log I/O. And it'll also show you long-running queries. So this is just based on time. And you can also go in and do a custom version of some report that makes sense to you and your game. So if we click in here on any one of these top 5 queries, you can see, hey, this is the actual query that's running that's consuming more resources than expected. Lots of charts and graphs of how many times it's run across an interval, how much CPU and memory it's using. And then you can copy and paste this into your SQL Server Management Studio or wherever you happen to be in order to start trying to optimize this query. And if you click on recommendations, you might see a recommendation over here. If it's a really high running query that's taking a ton of CPU, it would have showed up over here in the recommendations window. This one doesn't. It's not that bad. It's not bad enough to show up, apparently. So again, top 5 for all those. And then finally, automatic tuning, as I was just talking about, where you can tick that checkbox and say, no, just go ahead and do this for me. You can manage that through this interface here. You can turn it on or off. There's an inherit option, which means if you're running multiple SQL servers multiple databases on a single server, you can just set it at the server level, and all the ones that setting would cascade to all the databases. But then you can turn it on or off individually on specific databases. So if we go back out of here, that's one database. Pretty decent stuff for one database. But what if you have a giant pool of database servers or a pool of managed instances? So the next thing we have is Azure SQL Analytics. And to show this demo, this is a pool that has 38 servers in a pool with 1,400 databases inside of it. So we can click on that, and this will take a couple of seconds here to show up because there's 1,400 databases to collect data from. There we go. So this is a ton of information about your database fleet, essentially. So on the left column, you'll get the top metrics per database, so what's using the most storage or CPU. And you can click in on any one of these. Let me just pull one randomly here, one of the high CPU ones. And what you'll get is this insights report. And what this is going to do is tell you what it thinks is wrong and how it thinks you can fix it. So in this case, query duration has increased, main causes for regression user workload has increased and started piling up, hitting CPU limits, the affected queries are, and you get the hash list of queries that you can match over to the table on the right. And then there's a list of documentation that you can click through to learn more about what this performance insight is telling you and what remediation steps you might be able to take. So from here, again, you can click on any one of these queries. They're ordered however you wish. Look at the query, determine which database that query is running on, and find out information about CPU usage, data I/O, log I/O, just all this raw telemetry that you can use to try to figure out where this performance problem might be occurring and how you can fix it. Go back here. Oops. It's hard to see everything when I've zoomed it all in. There we go. Close that. So then there's also a graph here that shows you resources with performance issues. If we go into that, we can again see across subscriptions, across servers, across pools, and across databases where bad performance might be occurring. So I can go into one of these databases, see what pool it's in. I can drill into the database itself. And again, you'll start to get these insight reports, where this one thinks, attempting to write data to a database when the storage limit of the elastic pool has been reached. Well, you probably need to expand the storage capacity of that elastic pool in order to get rid of this error. And then the other thing you'll see is that automatic tuning stuff that we were talking about. But again, this has crossed thousands of databases, not just one. So you can come in here and see, oh, this top server here has 499 recommendations for us. So I can go in and looks like many of them are drop indexes that are impacting 51 different databases. And again, this interface is the same as the other ones we looked at, where we can see how to drop that index and what impact it would have on our database if we did so. So that's how you can see data across a ton of different databases in a pool. And if I scroll to the right here, there's just some other additional, just like more raw telemetry, a number of errors that are occurring, timeouts, blocking events, waits, things like that, that you can dig into individually if you wish to try to learn more about how your data is coming in and out of your database. And then the last thing I wanted to show was the threat protection that we have. So this, again, this is just a single database. And if we go to advanced data security over on the left, there are two types of things that you'll get out of this. SQL in the background will run a vulnerability assessment. So we have a list of a billion different things of how you can better secure your SQL server. And we check it against all the different instances of the server that are running, and we'll report back, hey, you don't have to, but it's probably better if you use TLS when you're talking to the database. You probably want that connection to be secure. Or, hey, you probably shouldn't use the DBO user for normal service operations because, well, you shouldn't be doing that. I think that was pretty obvious. You should never use that. So you can go in and click on any one of these things and learn more about it here. And then again, remediation steps on the bottom of what you would want to do. Again here, create users with low privileges to access the database instead of using the DBO one, obviously. So this is just more of a proactive approach to things that you might want to fix in your database. And then if we go back to the second table, which is advanced threat protection, this is more of a reactive. So imagine you had a login system in your game and you were unwittingly vulnerable to a SQL injection attack. This thing specifically is looking for things like SQL injection attacks. So from here, I can see that there were several, which were all me before running this session here today, where I can see that someone tried to do select star from table where username equals user and password equals empty or 1 equals 1, which of course would evaluate to true, allowing anyone into your database. That's a bad thing. So you get the IP address of where this happened, you get the query, and you get the information. Potential SQL injection query was detected. And then, of course, down here, there are remediation steps, which is a nice link to some documentation about how to fix SQL injection queries, which in this case would be how to sanitize input or something along those lines to fix the problem. So again, ton of information that you can learn about your database while your game is in production, learn about your data while it's in production to keep you safe and to keep you performant. And all that's just kind of included in the service. And again, all opt-in. You don't have to use any of it if you don't want to. So let me switch back here to slides. Now that we've talked about all those intelligence features, let's talk about MySQL, Postgres, and MariaDB. So these are the mostly open source databases that the world uses. Lots of games use MySQL and MariaDB. Again, these run on top of that database architecture that we were talking about. So you get a lot of shared features. You get that global scale. You get disaster recovery. You get some intelligence features. They're not as full-fledged as Azure SQL in terms of performance, or in terms of the intelligent features. Postgres has the intelligent performance, and it's coming soon to MySQL and MariaDB. And a major point here, if you take nothing more away from this slide than this one, these are the community editions of these databases. So whatever tools, SDKs, development process you're using today with MySQL, Maria, or Postgres, you can continue to use here. You change the connection string and you point it at the Azure version of it. So it's not like we have some custom SDK that you need to use or we're doing it the Microsoft way. You just use what you have and point it at the new version of the database and things work. And in the future, because again, we have this common database architecture, we can add other database engines into this whole ecosystem. So if there's one that's not here, let us know. We'll see if we can perhaps add it as a service in the future. And today there are 3 tiers for these databases: basic, general purpose, and memory optimized. Basic is great for development. General purpose and memory optimized are obviously where you want to be for a production game. 4 nines uptime SLA guarantee per server. You can scale from 1 to 32 or 64 cores depending on general purpose or memory optimized. Up to 5 or 10 gigs per virtual core of memory. Everything runs on remote SSD, so no spinning magnetic media that you need to deal with in terms of performance issues. Up to 5 read replicas inside the same region. And then on the bottom there's some information about versions of what we support today. We're updating all 3 of those this summer to newer versions of MySQL, Maria, and Postgres. So those will be coming along shortly. Next, let's dig into a little bit of Azure Cache for Redis. So Redis, we all know and love for in-memory databases. We, again, fully managed service here. No need to worry about patching. No need to worry about scaling this sort of stuff. It's all handled through the portal with sliders and checkboxes. You know, also go to the command line if you would prefer to do it that way. Super high availability. Redis has a primary and replicate config that you can set up manually if you want to. In Azure, it's a checkbox, so you don't need to stand up a second server and worry about how you're going to replicate that data. It just happens. Automatic failover, geo-replication, disaster recovery. Again, these features, we've talked about them a bunch of times. They just kind of come as part of the platform. And then availability zone support, which is where we have multiple data centers in a region. So if one data center exploded, I guess, it would automatically fail over to another data center in the same region. That's coming soon. That should be available relatively soon. In terms of scalability, zero downtime when scaling. So if you need to jump from a size instance of this to a larger size, you drag the slider, you click save. Doesn't take the service down. It just automatically scales it up. Same to go down. So between tiers and between sizes, no downtime for scaling up or down. And much like the MySQL stuff, 100% open source Redis. You don't need the Microsoft Redis SDK. You use whatever tool, whatever SDK, whatever development process you have today with Azure Cache for Redis. There's no need to learn anything new. You change the connection string, much like MySQL and the rest of the databases. And the final piece in terms of database services are NoSQL, non-relational databases. So our solution here is Azure Cosmos DB. That's the name of it. It's distributed, massively scalable, multi-model database service. What does that all mean? OK. So big points to make are global distribution, turnkey global distribution. You can replicate your data throughout the world with literally a click of your mouse. It is, I'll show the screen in a moment here, but it's crazy easy how it is to get your data from, say, West Coast US to Australia and have it be replicated automatically for you. Elastic scale out of storage and throughput. Storage and throughput are kind of, they're separate things. So you can start small. You can grow as your game grows. You can decrease as your game gets more towards the end of its life cycle. You don't need to predict what the usage is of this database. You can change it on the fly with no downtime. Oh, didn't mean to go to that next one. Go back, no. Guaranteed low latency at the 99th percentile, less than 10 milliseconds latency for reads and writes at the 99th percentile, super fast. There are 5 consistency levels. A lot of databases only give you 2, which is I need the most accurate version of this data. I'll sit here and wait for it. Just give it to me when it's ready. To, I don't care how accurate it is, I need it now. There's 3 other ones that live inside of that for Cosmos DB. Obviously, you choose which one you need. And you can do that even at the request level, which is kind of crazy. So you can set it up, well, I need this consistency as a database. But for this request only, I'll sit and wait because it's very important that I get accurate data. So you don't have to, again, predict. You can use what's required for that game feature. And then comprehensive SLAs. We have SLAs on availability, latency, consistency, and throughput. And on availability, we're up to 5 nines if you have a multi-region deployment. So as long as you're replicating somewhere else in the world, 2 regions running, 5 nines availability on that, which is crazy. And then you can store different types of data in Cosmos DB. If you're looking to store what we call documents, or just kind of JSON documents, all set there. Key value pairs, graph databases, or column family, all can be stored inside of Cosmos DB. You choose what you need for your data, for your game. And then there are different APIs you can use to access that data. So if you're familiar with SQL, well, you can write SQL queries against Cosmos DB to query your document collection. It's great. I mean, you don't get like full SQL. You're not doing crazy inner joins across multiple collections, and it's not that detailed. But you can select star from table where x equals y. And I say table, I mean collection. One day I will remember to say collection every time. But again, if you're used to that, you use that. If you know MongoDB, because you already maybe are running a MongoDB in a VM or something, we have an API for that. And much like all the other things I keep saying, these are implemented at the protocol level. So if you have a Gremlin SDK that you're using and you have some sort of work pipeline that uses the standard Gremlin SDK, you change the connection string and point it at Cosmos DB, and now you have the Gremlin API against a document database inside of Azure Cosmos, which is pretty cool. Again, like there's nothing new or special here that you need to learn. And this is the global replication slide here. This is a slide from the portal. When you want to replicate and do global availability across multiple regions, let's say you're on West Coast and you want Australia, you click the hexagon that's in Australia, you click save, and it happens. That's all you need to do. There's no service to set up. It just magically happens. It's pretty fantastic. You can add or remove regions with no downtime, so you don't need to like take down your game because you want to scale out to South Africa. You just do it. And then in production, if a region goes down, within milliseconds, there's an auto failover that will happen here. The client will automatically get notified essentially that this region has gone down. It'll get redirected to another region that is now set up as the master region. So you don't even have to like manually figure out failover scenarios in your game. It just happens for you in Azure Cosmos DB. And then a few months back, we announced multi-master support. So even if one region goes down, all the other regions still remain as read-write replicas. You don't need to worry about, well, oh, if this goes down, well, all these other things are just reads. Well, no, you still can do read-writes against all the other regions, even if the master goes down. And one of our partners that's using this is Wizards of the Coast for Magic the Gathering Arena. Was anybody in the last session about Service Fabric and Magic the Gathering? Okay. So they use Cosmos DB exclusively as their back-end database here. So they're storing user data, transaction data, card data, all the match data that's currently happening, as people are playing in real time, all stored in Cosmos. Oops. There's about 20 collections that are all indexed on player ID for performance. That's just natural for them to read this data based on player ID. And there's a Service Fabric cluster that Matt and Eric talked about, which is kind of the front end that talks to the Cosmos DB over a secure connection as its back end. At rest right now, they're about 600 gigs at rest, about 2,200 transactions per second. Cosmos can handle far more than that, but that's where they are today. But the thing for them is it's all about the scalability. They don't have to predict how successful their game is going to be. They can start out really, really low and go into the portal as their game gains steam and picks up in usage. They can immediately scale that out, no downtime, and have their game be more performant and pay for what they use and not have to pay for a ton of server at the beginning when there's only 20 people playing the game. So just highly scalable, and that has worked out great for them. So I'm going to bring up Ram right now, who's on the Azure Cosmos DB engineering team. He's going to run through a couple of demos for you in the portal. And I hand it over to Ram.
Thank you, Brian.
Have fun.
Yeah. It's always a hard task when you're have to do justice to so many services, and I think you've been doing a great job. So hi, I'm Ram from the Cosmos DB engineering group. First, as a quick show of hands, how many of you have heard of or used NoSQL already in your games? Awesome, it's quite a few, and hopefully next year we have the whole room using NoSQL. So as cliche as that sounds, that is true, and hopefully we can dive a little deeper right now to show you the value of what Cosmos DB as the managed NoSQL database service of Azure provides. So I'd like to split this demo or snippet into three parts. One is developer productivity and how we can help simplify your architectures. The second is what's the scale which Cosmos DB can provide at production level. And the third is actually a little more interesting, which is how can I build machine learning pipelines on top of my operational data and on top of my production cluster without having to move around my data into multiple data stores for me to build machine learning pipelines for monetization or understanding player behavior, right? So the first part, going into developer productivity and developer experience. Much to like what Brian has been saying repeatedly, what we don't want is to expect you to have to learn new languages or learn new frameworks or tools to come and utilize the capabilities which we on Azure are providing. And that's where, as Brian was showing, we support multiple APIs. If you are familiar with MongoDB or Cassandra or Gremlin, and you can basically just lift and shift into the cloud while getting all the benefits of Cosmos DB as a platform, all the scalability, the latency guarantees, the availability guarantees, all out of the box. And then comes in the architecture simplicity, right? Which is because of the fact that we are giving you financially backed SLAs on latency and availability, you can now have a single database service, which is your go-to for your production data as well as so basically your hot and warm paths can be served from a single data store without having to move it around into multiple places. So that reduces the cost. And also now when you're building your application, you just have to talk to one single database. So you do not need a cache in the middle. You do not need a middle tier service in the middle. So it basically simplifies your architecture to a great extent. And one thing which we also provide is a REST API. So we have SDKs in all the languages. So if you look at .NET, Java, Node.js, Python, C++, but we also happen to have a REST API. So imagine you're building a game within the Unreal Engine. And so this is an example where, do I just do F5?
Click on the window, click escape.
Okay. Yeah, so this is actually a demo which we built, and you can come over to the booths in the Microsoft Game Stack area, and you can check this out. What we have actually done is shown this at scale. Some of the demos which I'll be showing as well, which you can dig a little deeper. This is to just show you that now you can do reads and writes directly from within your Unreal Engine or a C++ game client by accessing the REST API. And it's very simple. You just have to point it to the connection string and specify whether you're doing a GET or a POST request. But if you want to go more further and you want to take advantage of the more complex aspects, you can basically utilize the SDK, which does a lot of the heavy lifting for you. Now let's go into the scale aspect, right, the second part. So typically especially when you go into large scale, all of this looks good when you're talking about, say, a gigabyte of data or a couple of gigabytes of data. But how is it easy for you to scale to terabytes of data? And because Cosmos DB is not a scale-up system, it's a scale-out system, we do not place any restriction on how much data can eventually go into a single database. So you start small. So you're building out your game, you're doing development testing, you take 10 or 20 gigabytes of data, and then you go into production, and then your game goes viral. It spans now into hundreds of gigabytes, terabytes, hundreds of terabytes, and also the throughput to which you expect out of the database can increase. So you could go from 100,000 requests per second to 1 million or 10 million. In the past, what you would have to do is manage the cluster yourself. You would have to, whether you're doing it on-prem or even if you're doing it on VMs in Azure. The thing is, it's great, you can do it. It's just that you now have to have DevOps or other infrastructure engineers always by your side to scale this up and down, because that has a huge impact on your cost. But what if we told you, you don't have to do all of that, we will do all of that for you, and you just have to basically read, write data, and we give you a lot of the guarantees. So in this, what we've actually set up is a Cosmos DB collection, which is equivalent to a table which is spanning 9 different regions in the world. And in each of the regions, we've basically set up a simulation, which is basically simulating player action data, both reads and writes in each of the regions. So what we can see here again is on a single collection, you have 119 terabytes of data, and you're basically serving 82 million requests per second from that single collection. And while we're doing that, if you look at the replication aspect, right, this is what I was mentioning. We have the collection is spanning 9 different regions so Cosmos DB is present in every single Azure region. So you can basically, if tomorrow you decide you have to go to Brazil, you have gamers there, you want to give them a low latency access, all you have to do is add the region, and we will seamlessly replicate the data to the new region, all your historical data, as well as any new requests which are coming in. And then comes in, as I was mentioning, the scale. So how would you interact with Cosmos DB? As in, how would you tell us that the throughput you expect, or your game is going viral and hence you need extra throughput, right? You do not have to manage the cluster. All you have to do is this slider, which we have a currency called the request units per second. So imagine your game goes viral, and so you expect 10x the throughput out of your database. All you have to do is add a 0 and click save. And we automatically scale out the database behind the back while in production. So you still get the past throughput, and you immediately get the new throughput while we scale out and we rebalance all of the data. And in the future, you expect lower throughput, and you want to pay us lesser as well. All you have to do is reduce the zeros, and basically you can scale up and down instantaneously. Now comes in basically while we're doing all of this, right, what about the latency? So you saw it's 80 million requests per second out of a collection. And we said we give you a financially backed SLA on the latency. So basically, if you see here, this is the end-to-end read latency at the 99th percentile. So the SLA is the darker blue line, which is 10 milliseconds. But what if I actually see what's happening? So you see here, the reads are typically taking 1.85 milliseconds, or like less than 2 milliseconds. And the same is true for writes. If I see what's the write latency, it's typically 5 milliseconds. That's pretty awesome. We're really excited that you can take advantage of this. And this is why we say you can now build a planet-scale game which is much more efficient, and you can build it out faster because we are doing all of this behind. You don't have to manage or maintain any of this, while we're giving you an SLA that this will definitely be provided to you. Now comes in a little more interesting aspect about consistency, right? Which is, as Brian was mentioning, what if I have data across 9 regions, and I'm writing data, say a player is writing data to East US. How fast should that data be ready to be read in another region? That's configurable again by you. Typically, databases have the strong and eventual consistency, but we introduced 3 new consistency in the middle, so that based on your exact scenario, whether you're doing matchmaking, whether you're doing storing player profile data, you may have different requirements out of the consistency level. So here again, depending on your scenario, you can choose the right consistency level. And this is just an example, right? And what does this mean? So this is eventual consistency. And imagine the writes are happening in East US in the first row. And the remaining 3 rows are showing you basically how will the reads look like if I was to read it from a different region. As you can see in eventual, you have no guarantees. You may read a stale data because the data may not have replicated to the right region. But on the other hand, if you go to strong, you can see basically you will always read the most recent write. But that may not be a requirement, and hence you can basically choose the right consistency level based on your need. And imagine you're doing eventual consistency, and this is again the part. You can say, I can stand up my own replicas of my database in all 5 regions, and I will do the replication on my own. But can you get the same latency? Not really, right? Because as a native service, we do replication at the transport layer and not at the application layer. So imagine, so in this, and this is the cool part, we show all of this on our metrics page. This is basically if you spin up a Cosmos DB collection, you go to the portal, you can see all of this. Here we're showing you you can look at the replication latency between any pairs of regions you have chosen, right? In this case, we're looking at the replication latency between East US and say UK South. This is what's cool. Even if you go to the eventual consistency, you can see by approximately 60 milliseconds, your writes are replicated to UK, from US to UK. So you're within 60 milliseconds, if someone is reading that data, they're going to get the write which you performed in East US. And this amount of replication latency is possible only because we do it natively at the network stack and not having to do it at the application layer stack. And this is actually a cool feature which Cosmos DB, compared to our competition as well in the other clouds, this is one major differentiator which we provide right out of the box, because we are a born in the cloud database service. We did not build something on-prem and we're now stitching it into the cloud. So those are some of the real good benefits you get when you move to a born in the cloud database. So that's real good database talk. I'm not sure how many of you are really excited by the database talk, right? But I hope you see the value which that brings to you at the end of the day now. And now comes the third part of predictive analytics. Now, there are different aspects of this, right? There's monetization. Can I predict? So I'm storing, imagine, player profile data. Can I predict in real time what is the probability that a new player will make an in-game purchase? Or you want to basically predict player behavior, whether you want to predict whether he's cheating, whether basically he's having a bad experience from the game, whatever. The cool thing we're saying is you do not have to move your data around. You have your data in Cosmos DB, which is the managed service. How many of you are aware of Spark? So Spark is, for those who are not aware, Spark is basically the open source go-to analytics framework today, because it's a distributed compute framework. So you write an analytics job, and it gets executed across multiple compute nodes. The cool thing now is Spark, being distributed compute, works really well with Cosmos DB, which is a distributed storage platform. So which is why we've basically built a native Spark connector, where essentially fetching data from Cosmos DB into Spark is just a single line of code. All you have to do is just specify which Cosmos DB collection you have to hit. Here I have a collection which is storing purchases information in the past, and you can write a query. This is what's cool again. With Cosmos DB, you can run SQL queries on top of JSON data. So this is a simple query. I'm just doing select a set of properties from this collection, and all you have to do is a single line of code which says read this data, and now your data in Cosmos DB gets materialized in Spark, where the heavy lifting is done by Cosmos DB to run the query. The results are streamed back into Spark. So now that you have your data in Spark, typically any machine learning pipeline involves like 3 stages, right? You fetch your data, you prep it, you split it into test and train, and then you basically go into model selection. You basically test out multiple models. Imagine you're doing classification, you do logistic regression, you'll try out multiple models, and then you would say, this is the model which gives me my best accuracy, and then you would basically deploy that model out somewhere. So that now that model is ready, you can just, if you have a new record or a new profile information about a person, you basically just run it through the model in real time to get the prediction of, is this guy going to be making a purchase? If so, I probably should show him more items near him. And this is where, again, it's super easy. Now, this notebook is just, you'll see how simple it is. Typically, when you do this in production, you would go through more steps. You would basically do more feature selection. You would do more model selection. But this is just to show you how easy it is to get started, right? Which is, once you have your data in Spark from Cosmos DB, you split it into twist and train. And then, again, Microsoft, basically, we've come up with a Microsoft machine learning library, which gives out-of-the-box machine learning tools. So that even if you are not an ML expert, so once you have decided that I want to do classification, I'm OK with doing a logistic regression, all you have to do is basically supply the training data set to the model and let it fit it and basically show you what the accuracy for it is. Now, we have further additions to this. In Azure, we basically have Azure Machine Learning as a service where you can say, I don't know any of this. I have to do classification. You auto-train the model. That's the next step of this. And we basically do that out of the box as well, where you just say, you do your own. So basically, it's like a recommendation service for machine learning, where you just tell us that you want to do classification. It tries multiple models, multiple hyperparameters, and ends up spitting a model which gives you the highest accuracy. So now that you have that model, again, this is super simple, where the Microsoft Machine Learning Library now allows you to basically deploy this model you have trained as a distributed web service. So basically, it spits out an endpoint, and now you can submit a document or a JSON request to that model and get back a prediction. So once I have deployed this to, say, port 889, I can now submit a query to that to get what the result is. And how do I do that in a production system? Basically, Cosmos DB, this is the cool part. Typically, databases will allow you to write queries on top of it, but they do not have a kind of a messaging system on top of it. Cosmos DB has this capability called change feed, which now allows you to basically get a stream of updates. So as production reads and writes are happening, you can now read out a stream of exactly what's happening. So you can, when a profile gets written in the database, you'll now get a trigger which is saying something is written. Now you can now just pass this through the model and get it scored. So now in real time, you can now predict what is the probability that XYZ is going to make an in-game purchase. That's pretty cool, right? Now this is how many lines of code? Super simple. You can play around with this. We'll be publishing this as well, where you can go get started with this and really get your hands dirty. And hope that was cool and you got something new out of that. And so back to Brian.
Good job. Thanks, man. All right. So that was kind of machine learning and trying to predict player behavior. So just more of a prediction model type of machine learning and what you can do with that data. What I'm going to circle back to now and show you is what you can do more with visualization and analysis of telemetry data. So this is more about how healthy is your game? Are players having a good experience in the game? Are your servers running? Are they returning errors? So ways that you can analyze telemetry and learn more about your game. So there's a couple of visualization products we have. Power BI, which is a nice dashboard interface where you can create reports and queries and get lots of pretty charts and graphs and maps and things. So just a great way to visualize your data instead of looking at it in a grid, essentially, as you normally would. We also have a service called Azure Data Explorer, which allows you to ad hoc query telemetry and log data and visualize it, but it's not quite as feature-rich as Power BI in terms of what you can visualize. So all these things together, everything Ram just talked about, all of our visualizations, and a bunch of services that we haven't even talked about here. The point to make here is that we want you to turn your game data into action. So in all of this, have your games send data to our cloud. And you can ingest them through things like Event Hubs or Data Factory. You can talk directly to Cosmos DB or the databases if you want to from a back-end service, whatever's right for your game. Put it into one of our many storage engines, Cosmos, SQL, MySQL, et cetera, and then learn from that data. Apply things like Machine Learning Studio, Spark, as Ram just talked about, Databricks, and other services. We have a ton of things called cognitive services, which will, again, I'm not a data expert. I'm not a machine learning expert. Cognitive services are these services where you just send it stuff and it tells you more about it. So you can send it images and it'll tell you what's inside of that image without you like training models. I don't know if everybody watches Silicon Valley and not Hot Dog. You don't have to be in a situation where all you can recognize is hot dogs. So we do all that for you. And then in addition, with all of the dashboards and visualizations and query tools like Power BI and Azure Data Explorer, take all of that telemetry data, learn more about it. But the final step here is then take all this information and apply it back to your game. Take that player prediction and ensure that the person who's playing your game is going to buy that costume. Ensure that person's going to pay for the DLC that's going to come out next month and advertise it to them because, I mean, the whole point here, we all love games, but there's obviously a component where you need to make money to pay for all this stuff. So take all that data, learn from it, apply it back. And it's not even just about monetization here. It's also about learning, hey, is this game performant? Are people getting kicked off servers? Are people having super high latency in my game because I haven't properly set up, or I may need now to set up a region somewhere else in the world in order for them to have a better experience. Learn from all this stuff and apply it. So one of the companies that does this heavily is Rare with Sea of Thieves. They're a Microsoft Studio subsidiary now. But essentially here, they have a super highly instrumented game. They're collecting telemetry data all the time, which has helped them improve this game through its life cycle. This is a game, obviously, that runs in the cloud and has a longer life cycle than just maybe a single-player game would. So they're constantly pulling in telemetry across three areas. The game client, that's the thing that's sitting on your Xbox or Windows 10 machine. The game server, that's the multiplayer server where all the players are connected to at a time in the virtual world. And then services, which they use Service Fabric pretty exclusively in terms of managing player progression. Ensuring that items that are collected in experience that's gained and points that are gained are all stored separately off in its own data store. So from the client, they're doing things like tracking boot flow. Are people getting into the game without errors? Frame rates, memory usage, things like that. Just kind of what you would expect out of a client. Are they also interacting with new UI that they add, or if they add a new quest or a new thing? Are people discovering and finding the things that they should, and are they successful with it? On the server, they're making sure people are, again, discovering features, but they're also adding ETW traces, event traces for Windows. So they're looking at memory and frame rate stalls and crashes and things like that might happen on the server. And then all those game services are looking at all the events that are being passed back and forth inside of Service Fabric and to all the other microservices, as well as just more ETW services, or more ETW events. And they use Power BI and Azure Data Explorer to make sense of this ton of data that they're collecting all the time. So I've got a screenshot here, and I apologize for the blurriness, but it's the best I could do. There are three graphs here that they sent me that kind of drive this point home. And that's this first graph on the top is the percentage of concurrent users that are exiting the game at any given time. And that's typically 1.5% to 2%. Just because people get done with the game, they're going to sleep, they're moving on with their life, people obviously are going to quit the game at some point. That threshold, that red line you see across the top, is that 2% threshold. Across all those many intervals, if they start seeing persistently that players are exiting the game at more than 2%, there's probably a problem with the game, is what they have figured out. Either they're getting kicked out, or they're having a bad experience, and so they're leaving because they're not having any fun. There's something negative that's happening. So with this information, they don't need to set up a trillion telemetry events and have people getting emails and text messages in the middle of the night that's something wrong. They still have that, But the point here is that these graphs tell the story. So they don't need to necessarily set up a billion different events, and can also determine whether or not these things are transient. So you might have an event set up, everyone gets emailed, but that above 2% happened for 3 minutes, which just might be a glitch in the matrix, just something bad happened for 3 minutes, and so there's really nothing to fix. It's just a bad thing that happened because, well, the internet, I guess. So the second graph here is the percentage of players that are getting an error when trying to log in. So in general, it's about 0.3%. Again, just because stuff doesn't work all the time. There are network issues or a service issue or something. That threshold, there's a line there, a blue line, reddish bluish line there. That's that 0.3% threshold. They know if that people are having errors logging in, it goes above 0.3% for a persistent period of time, they have a service issue they need to go look at. And then the final graph is just the ratio of players that are receiving any errors versus players that are receiving no errors. So again, they look at this, and if that proportion starts to get a little out of whack, they realize there's something that they need to go explore and find out what's wrong. And so how do they do that? What's really interesting with them is their backend is built almost exclusively with Service Fabric, which you learned about in the previous session. So they make a hypothesis when one of these things goes haywire. And they have a billion more of these dashboards. They just sent me these 3. They form a hypothesis of what could be wrong, what's broken about the service. And then using Azure Data Explorer, which is this ad hoc query engine, they can look at all that telemetry data that they're collecting, run a query, and prove it yes or no. But sometimes they need more data. Maybe they're not collecting that data at the time. What's super cool about Service Fabric is they can take a microservice, add code to now collect that data, deploy it out to the Service Fabric cluster, and within a couple of minutes, all the players are going to start hitting that new version of that Service Fabric microservice that's in there. And then they start getting telemetry data. I mean, they say within a couple of minutes, they can now view that data in Azure Data Explorer, run those queries, and determine where the problem might be. And if they're proven right, they fix the problem. If not, they might add more telemetry data and do that whole process all over again until they find out what the actual problem was. So they can kind of diagnose, debug, and fix this game in real time, which is pretty fantastic. So the summary here, I'm going to drive home the same points that I made previously. Bring what you know. You don't need to learn anything new. Again, with all the services that we have, if you're using Redis or you're using the open source databases, you want to use Cosmos and use one of the existing Cassandra or other APIs, you just use it. There's no special Microsoft way to do it. Bring what you know to our cloud. Let us help you manage it. Make sure it's secure, scalable, and reliable, so you're not spending all of your time making sure that servers are patched and whatnot. Let us handle that for you. Learn more about your players and games and turn that into action to improve your game, both from a monetization and from a service effort. And finally, spend more time where it matters. Spend it on your game, spend it on the creativity, spend it on making your game better overall. So I have some links here. I'll leave this slide up here for a second. If you want to learn more about GameStack, which is kind of the umbrella for all of our gaming services and platforms, you'll get more information at the first link. We have a new gaming docs portal at that second link, so if you want to learn more about how to use Azure for games, learn more about PlayFab, Xbox Live, all of our cloud services, as well as even client things like DirectX and whatnot, they'll get linked from there. And if you want to learn more about databases, our analytics service, the machine learning stuff that Ram talked about, Power BI, again, all those links available there.